Part of our Intelligent Track survey series, we're now going to run through a demonstration of a full virtual reality model of a railway depot. To discuss with us the construction of the model is Martin Scampion. So Martin, take it away.
Thank you. Okay, this is a model of North Pole Railway Yard. The track areas will have come from CAD data, which gives us the layout and exact details of the track, points. Augmenting this is aerial photography, plans, and if it's already built, we will go there and take photographs of the place itself. Often we'll be building these scenes and they won't exist, so the database will be done partly to aid the architects and planners of the area, and afterwards be used for training drivers and for testing signals and signs later on in the process. So you get double value for money for the project. And it's very often that they do find faults with the original plan while having built this first.
So the data that you require to build it is just any form of CAD data that is available, whatever?
Ideally it'd be CAD, because you know that the axes that the planners have defined.
Okay.
If it haven't got that, then there'd be plans that we can scan in and take information from, aerial photography, and say if the place is already in existence, we can go there, we can do measurements, we can take photographs.
Right.
We always have to go to the site to take pictures. If it hasn't been built, we will get equivalent building photographs and signs and signals from other sites.
Okay.
We will always start with real photographs to do individual pieces. The photographs are then used to form what we call a texture, which is laid on top. So you can see that's how it looks without the texture. The whole scene is made up of multitudes of triangles, and you can actually see these triangular shapes. For instance, the building, you can see how it's built up, triangles, and then the texture is fitted on top. And from that we end up with complete 3D shapes, which we can then drive through.
And the level of detail that you build into these models is entirely dependent on the end requirement, right?
Yeah, the customer will define the purpose of the project, whether it be architectural, whether it be for measuring sign distances, sign positioning, training aids, whether it's testing surprise things coming on the track, people, animals, fallen trees, whatever it might be. The better the data, the better the end result always.
Okay.
But yeah, we can build it from almost any data. Customers usually sit here with us at certain points and we'll do reviews, and so all too often if the place hasn't actually been built, that can lead to architectural and structural changes, because this could be the first time they've ever driven it.
So it can be used as a tool at the design stage?
Yeah, all too often it is. Quite often they'll come on something like this and they'll realise that actually that would never work. What made us put that there? Just sometimes driving something makes you just see it in a totally different way, no matter how many times you look at a plan. It's when you see it in 3D you suddenly realise that actually, for instance, that sign isn't visible from here.
Sure.
That signal isn't visible from here, that wall's in the way, and that's never going to work. The level of detail we do, as you can see here, some points aren't accurate because the customer, in this case, said we will never use that track. We're only interested in this side. All things like points and signals are selectable, so the instructor can, at the last minute, move a point, and the driver has to use his eyes, not just assume he's got permission to go through that way. And the instructor can put on full signals to test the driver, as well as see if the signals are working at that range and in that position.
And if you find something that isn't working as it stands in the design, you can reposition it and you can compare it
very easily.
So Martin, could you now give us a quick demonstration of how you would go about placing a new signal into the scene and into a known location?
Yeah, sure. What I'll do here, I'll drive up this section of track and there'll be no light signal. Then I'll add in a 2-aspect signal, drive it again, and then we'll introduce a train that could block the view of that light. This time the view of the light is obscured by the train, and you can just see the light appearing in the distance. So here's a typical library model. These have selectable signals. And these can all be controlled by the host with lighting, very low polygon counts. This model itself is just 36 triangles. So it means capacity is freed for other features. Okay, so I'm just going to move this signal, and I can move it one of two ways. One, I can just simply select it, position it somewhere else, or I can actually move it an exact defined amount. So in this case I'm going to move it 20 meters in X. Immediately no longer obscured by the train in its new position.
Okay, so Martin, could you give us a quick demonstration of how you could move one of your objects, one of your items in the scene quickly and reposition it and show us the...
Yeah, sure. So okay, I'll move this building and get rid of the train. So here it is in my modelling tool. So I'm just going to get rid of that train. I'm going to select these buildings. I'm just going to move them from this point to this point. Now that could be an exact defined distance, it could be defined in down to millimetres, exactly how far I move that.
So if, for instance, we wanted to move a building or a signal, for example, 10 metres forward, you could do it exactly 10 metres forward.
To the millimetre. And now this is loading up again, you'll see the building is now moved and the train is now gone. It's that quick.
Brilliant, thank you very much.
Pleasure.